Okay, let's go through this review. Smitty loves football and tries to attend NFL games during the season. Right now, he has 6 football hats. After each year, he adds 4 more hats to his collection. So I could start filling this out right away. Remember, what I'm looking for here is words that help tell the mathematical relationship here. But I think maybe it's most helpful to start with a table. So we'd say, remember that our x always starts with 0, unless we know for sure it doesn't. But here we're going to assume that it's before anything happens. So before anything happens, before it's the whole thing starts, what do we know? Well, he says right now he has 6 football hats. So he has 6 now, and then each year he adds 4 more hats. So this is going to be 6 plus 4, which equals 10. And from this table we can start to figure out, okay, what is it that the relationship is for this? What we're saying is we're going to count what? This is 1 year, so that's our x. And this is the number of hats. So what we're saying is the number of hats depends on the years. So then this is going to be 14, this is going to be 18, this is going to be 22, because each year he's adding 4. So our domain is our range of, our domain is the set of x values. So we can write it like this. This is the way we've learned to write domain like this. Now, I just copied from my table, but there's nothing that says he can only live 5 years. So I have to think about this a little bit more carefully and say, you know what, actually, there's no real upper limit to the number of years you could maintain a hat collection. I mean, he could, pass it on to his kids or his grandkids or something. So since we don't have a theoretical limit, we're going to say it goes to infinity. And that means that the range starts with 6 hats, because this is our y, or our f of x. And it goes till, he's just going to keep adding hats and keep adding hats. So theoretically, we could say it goes to infinity. In practice, probably he's not going to live or maintain his hat collection forever. But since we're not given that, we have to just assume that it keeps going up. So this is the years. This is the hats. And we say year 1, 2, 3, 4, 5, 6, 7. And hats starts at 6 and goes up to 26. So if I went 2, 4, 6, 8, 10, boy, that means year 1 I'd already be halfway up my graph. So I'm going to try doing it every 4 and say this is 4, 8, 12, 16, 20, etc. So it's 20 to there, so it's 40 to here. So this is going to be, 24, 28, 32, 36. As long as I'm consistent with my scale, I'm okay. Years, so at year 0, he's got 6 hats, so that's right there. At year 1, he's got 10 hats right there. At year 2, he's got 14 hats. 3, 4, 5, 6, 7. Now, some of you are going to say, oh, look, I see the pattern, I'm going to draw the line. But hold off on that, because we have to answer our question. Whoops, not that one. That point is a problem, right? Because I'm saying that at 6.5 years he has some number of hats, but we don't know how he acquires hats, and we certainly know that he's acquiring a hat, one hat at a time, not a continuous growth of hatness. So he couldn't have 4.5 hats. He's either going to get 4 hats or 5 hats. So because of that, we're going to say this is a discrete function, and we're going to leave the dots as is. So I probably need to get rid of this one. Even if we were to count up by single hats, we would know that it's not connected, because you couldn't have 1.5 hats or 1 3/4 hats or 0.2 hats. So that's what it means by discrete. It has nothing to do with whether it keeps going. It's only about whether this would be connected or not. This graph is increasing, we can see that. At the y-intercept, that's right here because this is the y-axis. So what happens? We could say he starts collecting hats, or he has 6 hats to start. So going on to the equation, write an equation function notation that represents the scenario. Function notation means this, and we know he starts with 6. And then remember, we're adding 4 each time, and that language might help clue you in that it's 4 times x, because x is the years. So every year we're going to add another 4. After 10 football seasons, how many hats are in Smitty's collection? Well, you could try and figure out from the graph, but it's going to be hard to be precise about that. The best way is to use our function and to say, well, what if I put 10 in for x? And I've got 6 plus 4 times 10, that's 6 plus 40, so it's going to be 46. Describe what your solution represents. This is not much different than just restating what we just found. We say after 10 seasons, he has 46 hats. So this is what we talk about, making sense of the world mathematically. We want to be able to go both from the context to the equation, and from the equation back to the context. Okay, here's the context of a woman in an elevator 60 feet above the ground. The elevator ascends 5 meters. Well, there was a typo, so we're going to say it's 60 meters. And I've double-checked the test to make sure we don't have this typo. So it's 60 meters above the ground. The elevator descends. Well, obviously this is a decreasing function then. So that means it descends 5 meters every second. So that means the first, it's going to be at 60, and then it's going to be at 55, and then it's going to be at 45, and then, 50, and then at 45, and then at 40, and then at 35. So that means before it's descended at all, it's at 60. So this is going to be, and then how does it descend? 5 every second. So we know that this is seconds. And this is meters. Meters above, right? Above ground, because she starts at 60 and descends. So after 1 second, it's 55. After 2, it's 50. 3, 4, 5, etc. Now, we're going to know that we're still at 30. At 5 seconds, we're still 35 meters above the ground. So it's going to continue here. So if this is 60, let's go 10, 20, 30, 40, 50, 60. Okay. I'll put this at 60. So this is meters. I could say height or elevation or meters above ground. And this is seconds. Now, 1, 2, 3, 4, 5. I know that that one is going to be 35 meters. So if I'm looking at starting at 60, I go down to 35, I'm going to realize, nah, I'm going to run out of room. So I'm going to do every 2 seconds. So this is 40, 20. So 1 second is 55, 2 seconds is 50, 3 is 45, 4 seconds is 40, and so on. And this is going to actually tell us, bam, right there, 12 seconds. So that means at 12 seconds we know that we should get 0 meters. Now, this graph is continuous or discrete. Well, let's look at the context, because that's what tells us. Is an elevator, is it going to jump? Like hat goes from 4 to 5 to 6 hats? Or does it gradually, continuously keep going down? It continuously keeps going down. There's no way for an elevator to skip any of the meters. It doesn't teleport. So we're going to draw the line. That's what indicates that it's continuous. Okay, the dots indicate that it's discrete because there's no line. So this is a continuous function. And what happens at the x-intercept? Well, this is the meters, so that's at 0 meters. So elevator has reached ground. And then write an equation in function notation that represents the situation. So function notation is this. So just like we did up here, we say it starts at 60, and then what happens? Here we increase the number of hats, so that is a plus, but here we're decreasing. And we're decreasing by 5 meters. But not just by 5 meters once, right? If I just wrote this, that would be 60 minus 5 is 55. And what that would be saying is the elevator is always 55. It's not always 55. The elevator is 60 meters minus 5 meters per second, right? So every second you have to multiply by the 5 and figure out what you subtract. So after how many seconds is the woman exactly halfway down? Okay, so we're saying after how many seconds, that means we're trying to find x, because x represents the number of seconds. Is the woman exactly halfway down? Well, halfway down would be, right, she starts at 60, she goes to 0, so halfway is going to be here at 30. So this is 30 meters. So meters is what f of x stands for, or what y stands for. So we'd say 30 equals 60 minus 5x. So we have to figure out what is x in order to get 30 on this side. We can solve this algebraically. Some of you are going to be able to say, oh, look, I need to subtract 30, so that means this has to be 30, so it's 5 times 6. That's great, but let me just show you how we do this algebraically. Subtract 60 from both sides. I've got a negative 30 equals a negative 5x. Divide each side by negative 5, and I get negative divided by negative x equals 6. So there we are. We know that after 6 seconds, she's going to be halfway down. All right, let's turn this over. Another one. Raquel writes down her Instagram followers for 4 days in a row. She expects the trends to continue. 22, 27. Okay. So we already have the second day. Now this says day 1, so it means after 1 day it went up to 27, so that means day 0 she was at 22. And as we're doing sequences like this, it's very much similar to functions, so we always like to have f of 0 in there, right? What happens to start? So 2, 3, 4, 5, these are days, right? And you can see it's going up by 5, and then by 5, by 5, so it'll be 42 and 47. So it's going up by 5, so we could say this is a plus 5, right? That's the change, which means it's plus 5 here, plus 5 here, plus 5 here, plus 5 here, plus 5 here. How many plus 5s are there? Well, it depends on the days. So days is going to be x, right? Number of followers is f of x. So f of x equals the start plus the increase times x. How many Instagram followers does she have on day 46? Okay, so we said x is going to be the number of days. So now we're not saying the outcome is 46. We're saying the input is. We're trying to figure out the output, the followers. We can write this like this. We say f of 46 equals, and then I've got my function here, so it's 22 times 5, and then we said we're putting 46 in place of x times 46. Well, that is going to take some calculating. I don't really feel like doing the mental math right now. So we're going to 5 times 46 equals 230, so 22 plus 230. So that equals 252. So that means on day 46 she'll have 252 followers because she's going to keep increasing by 15 if the trend continues, which she expects it will. Okay, the following function represents the temperature in a room. 78 plus 26x. That's going to be one hot room. If it helps, use any tool table graph to answer the following questions. The function is increasing or decreasing. So, if a table is going to help you, make a table. Say, what if x is 0? That's 78. What if x is 1? Well, that's going to be 78 plus 26. So 78 plus 26 equals 104. And then we add another 26. 78 plus 26 times 2 is 130. Well, this is definitely increasing. You could also do a graph. You could say, okay, well, here's 78. And 10, 20, 30, 40, 50, 60, 70, 30, 40, 50, 60, 70, 78. And then it's going to go up by about 26. So there's about 20. So 20, 26 is going to go up about like that. Here's 1, 2. So okay, so we can see that it's going increasing. And the y-intercept, right, this is when x equals 0. The y-intercept is 78. Technically, we could write it this way. Here's our x value, here's our y value. But 78 will work just fine for our purposes. So, last one. A savings account is opened. Then monthly deposits of 11 are made at the end of each month. The graph shows the sequence. Please note the scale of the vertical axis. Okay, we're going to note the scale of the vertical axis. So we're saying the balance after 1 day or after 1 month is 74. So we could write this as a sequence in a chart, right? We could say 1 month is 74, 2 months is 85, 3 months is 96, 4 is 107. Okay, so in order to write this function, we need to know what is it that we started with. If you look here, you say, well, this is plus 11, and this is plus 11, and this is plus 11. So that must mean this was a plus 11. So if I work backwards, that means this is going to be 63. 0, 63. And why is that helpful? Well, if I'm going to write a function notation, I need to know what our starting point is when x is 0, right? So that I have 63 plus some number times x, but when that's 0, when x is 0, that means that whole thing goes away and all I'm left with is the constant. Well, which number is that? Well, it's going up by 11. So, 63 plus 11x. Here we are. After how many months will the savings account have a balance of 173? Okay, notice that we've got labeled graphs here. So balance is the y and time is the x. So if I put a 173 in for x, I would be saying that's 173 months because x is months. It's time in months. That's not what I want. I'm saying it's $173. So we have to read this carefully and say, okay, which does this go in for? And this goes in for y, or for f of x. So we're just going to say $173 equals 63 plus 11x, right? When are we going to get to $173? Well, it's going to be $63 to start, because that's what it was. We figured backwards. And then each month we add 11. So 1 month we had 11, 2nd month we had 22. So let's solve this algebraically. Minus 63. 110 equals 11x. Ooh, I like this. Look, they're nice and neat numbers to divide by. So we can divide by 11, and we get x equals, what do we get? 10. So 10 months. So there you have it. There's our test review. Good luck on studying that, and good luck with the test. Remember that if you put the work in ahead of time, you have every reason to come into the test to be confident and calm and not anxious at all. If you've been there in class, you've been participating, I'm confident you'll be able to do well. So, good luck.